In today's video, we are going to be talking about special angles. Now, this is another aspect of trigonometry, okay? If you know you didn't watch the first video, I advise you to do that. That's an introduction to trigonometry. It's to give you the basics to whatever we're going to be doing here, okay? So that anything to talk about will not be new to you. I advise you to watch that first. Now, here we're only going to talk about special angles and everything that comes with it. Now, what are special angles and what are they used? Now, before now, you've noticed that you find the cosine or sine or tangent of some angles, and then you get some answers, okay? How are these answers obtained? Now, there are a few angles, okay, in degrees. We're going to work in degrees that you might need to take note of, okay? And these ones are easy to remember. They are usually in short form, okay? So these things are angles that we need to take note of, and from these ones we can get the cosine or sine or tangent from other angles. That is why they are called special, okay? It's something you can practice, and with time it gets into your memory, okay? Now I'm going to show you how these things are being done. First of all, I'll list out the angles we are going to deal with. We're going to deal with 0 degrees, okay, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. Now I'll show you how these things are being done, how you can easily calculate them even if you forget, okay? I'll show you how they are all being treated. Now let's start with 0 degrees and 45 degrees, okay? Now to do that, I'm going to draw a triangle, a right angle triangle, okay? Here we are having a right angle triangle of which here is 90 degrees, okay? Now in this right angle triangle, two sides are going to be equal. That is, the opposite and adjacent are going to be equal, which gives us a kind of triangle which is called the isosceles triangle, okay? Right? Because two sides are going to be equal. Now why are these two sides equal? Because I'm going to call these angles the same thing, 45, 45. If they are equal, both angles need to be what now? 45 if here is to be 90, because when somewhere between you get 180 degrees, right? Now for these two, if these two guys are equal, that means if here is 1, here has to be 1, okay? And then if here is 1, here is 1, using the Pythagoras theorem which I gave before, a squared is equal to b squared plus c squared. This was done in our previous video. Now a squared is the longest side which we are looking for, a squared. B squared is what now? 1, so a half squared plus 1 squared. That gives you 1 plus 1. So a squared is equal to 1 plus 1 is 2. From here, a is equal to the square root of 2. So I'll come here and I'll write the square root of 2. Okay? Now, remember our SOHCAHTOA again. SOHCAHTOA, which we talked about in our first video as well. SOHCAHTOA. This is a short way of remembering the formulas for calculating sine, cosine, and tangent. Sine is opposite of hypotenuse. Cosine, adjacent of hypotenuse. Tan, opposite of adjacent. So let's start for sine and see what we're going to get. So if, for example, we are to find the value of sine of an angle, example, let's say sine 45 degrees. Okay? So if we are to find the value of sine 45 degrees, what will be the value? Okay? Now we just said sine is opposite of hypotenuse. So from this triangle, where is the opposite? We can pick any side as our opposite because everything is the same. If I'm using here, here is my opposite. If I'm using here, here is my opposite. So sine 45 is opposite over what? Hypotenuse. So sine 45 simply gives us 1 over what now? Square root of 2. Of which this can be written in decimals. I think that will give you 0.707. Right? Okay? Now, how about for cosine 45? Cosine of 45 is what? Adjacent over hypotenuse, right? Initially, sine was opposite of hypotenuse. Now, cosine 45 adjacent over hypotenuse. So we can also pick any other side, adjacent over hypotenuse. That will give us the same thing. 1 over the square root of 2. Now that is equal to 0.707. Most times you don't remember the decimal form, so I advise you leave it in short form, okay? It won't really change anything. We have 1 over 2, 1 over 2, and then we have these guys. Okay? That is how it is being done. So cosine 45 is also what now? 0.702. So you see that sine 45 and cosine 45, they are having the same value. Now how about for tan 45? Tan 45 degrees. Now tan 45 degrees, you can make use of any of these ones. That's opposite over adjacent or adjacent over opposite, depending on which side you are taking. Tan is opposite over adjacent. So that becomes 1 over 1, which gives us what now? 1. So tan 45 is 1, cos 45 is 0.707, sin 45 is 0.707 as well. Now we succeeded in what now? Finding the value for this angle, 45. How about 30 and 60? That's the next one we're going to talk about. Okay? The one for 30 and 60. Now to do that, we're going to draw an equilateral triangle. Okay? By now we should know the different types of triangles. So when I mention an equilateral triangle, you should know what it is. Okay? An equilateral triangle is a triangle that has all its sides and angles to be equal. Okay? So for an equilateral triangle, here is 60 degrees, here is only 60 degrees, and then here is what now? 60 degrees. Okay? Now for this equilateral triangle, we are going to assume all the sides to be 2 because I said all the sides are equal, right? So if I say here is 2, here is 2, and here is 2, this is what I'm going to get. We can as well bisect this triangle, okay? This is what we call a perpendicular bisector. Now, what is a perpendicular bisector? A perpendicular bisector is a line that splits both an angle and a line into 2 equal parts. So if I should make use of a perpendicular bisector, because I use the word perpendicular bisector, it means if I'm dividing this into 2 equal parts, if I'm dividing this rather, I'll get 2 equal parts. Here is symmetrical to this other side, okay? So here, we're having what now? 260. Now the angle becomes half because I just divided it, that's 30. And this one becomes half again, that's what now? 30. So I can bring one of these triangles and work with it. Remember, this line is also being divided. So we have one here and we have one here, right? If I bring out one of these triangles, I'm going to get something of this sort. Let me do it here. Okay, taking the left hand side, I'll get 60 to 130. So I'll have 60 here. We have 2, we have 1, and then we have 30. Now what will this angle? This angle will be 90 degrees. Why? I made use of a perpendicular bisector. Okay, so it is perpendicular to what now? The horizontal line. Hence here is 90 degrees. That is, it is what now? Perpendicular. Now from here, let's find the value of these 3 guys again. Sin 30, cos 30, tan 30, and the likes. Okay, so from here we can say that sin 30 degrees will be, what will be sin 30 degrees? Sin 30 degrees is what? From slope as well, it is opposite over hypotenuse. So this 30, this opposite, and this hypotenuse. So sin 30 becomes what now? 1 over 2 or 0.5. Okay? Now, how about cos 30? Cos 30 degrees becomes adjacent over hypotenuse. Now, this 30 degrees. Okay? Here is 1, here is 2. Oh, we did not find this part. Now, what will be the value of that part? We're also going to make use of what now? The Pythagoras theorem to find this last part. To do that, we are going to say that a squared is equal to b squared plus c squared. Now, a is what now? 2 squared. B will be this side squared. And c will be what now? 1 squared. Okay? Now, 2 squared is 4. So I have b squared plus 1 squared, which is 1. So from here, we have 4 minus 1, that's 3, equals b squared. So b is equal to square root of 3, okay? So I'm going to take here to what now? The square root of 3. Now, how do we find cos 30? Cos 30 is what now? Adjacent over hypotenuse. If here is opposite, here is adjacent. So that becomes what now? Root 3 divided by 2. Now, in decimal, this is 0.866 approximately, okay? Now, how about tan 30 degrees? Tan 30 degrees can be found as well. Using what now? So opposite over adjacent, okay? So we can come here, tan 30 degrees, here is my opposite, okay? And here is my adjacent. That's 1 over root 3. Okay? That's tan 30 degrees. Or most persons want to rationalize and move this root 3 from the bottom. So if you multiply the top and bottom by root 3, you're going to get root 3 over 3. So whether you see 1 over root 3 or root 3 over 3, that is the value for what now? Tan 30. Okay? And you can as well put that in decimal if you want to find the square root of 3 divided by 3, write it. And let's move on to 60 degrees. So for sine 60 degrees, what are we going to do? Sine is what? Opposite over hypotenuse. Since I'm dealing with this angle, I explained in the previous video how you are going to identify your opposite. That is why it's important to watch that first, okay? So sine 60, since I'm dealing with this angle, here becomes our opposite, no longer 1. So this is what now? Opposite over hypotenuse. So we're going to have root 3 over 2 or 0.866 as our sine 60 And then for cos 60 can be found as adjacent over hypotenuse. So here it becomes our adjacent over hypotenuse. That's 1/2 or 0.5. Okay? And then for tan 60 degrees is opposite over adjacent, right? This is opposite, this is adjacent. So we have √3/1, which is equal to √3. You can also write in the decimal form by punching your calculator. Okay? Now these are the various angles. We just succeeded in finding the one for 30, 45, 60, and then we're left with 0 and 90 degrees. Okay? Ladies and gentlemen, we do not find the value of sine, cosine, or tan of these angles using the triangle, using this method I just showed you. No, you don't do it. Okay? There are other ways of doing them. Or I use trigonometrical formulas, which we call compound angles. Now, compound angles is something we're going to do in our next video. Okay? And then, or we could make use of the graph. So in this video, I'm going to make use of the graphical method for finding 0 and 90 degrees. Now, to do this, you need to know how the graph of sine, cosine, and tangent, how they all look. Okay? I'm going to come here and I'll start with the graph of sine. Okay? Let's start with the graph of sine. Okay? So for sine, the graph is something of this sort. It starts from the origin. Take note. So have 0 here. Now here to here is 90 degrees. Okay, that's half 1/4 of a circle. Here we have 180 degrees. And here we have 270 degrees. And here we have 360 degrees, and so on and so forth. Now this is the graph of sine. Now, how do we find the value of sine of 0 degrees or 90 degrees in this case? Here is how it is being done. We'll go to the angle we want to find. We'll trace it upward and down. If it touches any of this curve, okay, we'll pick it as our answer. But if it does not touch anyone, our answer becomes 0. Okay, so I'm going to start with 90. Okay, so for sine 90 degrees, trace this point. Okay, here is where we have 90. So when I trace it downward, there is no what now? Curve, so it does not touch any place, right? But when I trace it upward, it touches the curve. When I trace it back to the what now? To the vertical axis, the value here is 1, the value here is 0, and the value here is what now? -1. The range of values for sine and cosine is always range between -1 and +1. There is no way you are going to find the value of sine of an angle and you get an answer that is what now? Less than -1, or an answer greater than what now? +1. That is why here is the restriction. Okay, so sine of 90 degrees, when you trace it to the top curve, you trace it back to the vertical axis, you get what now? +1. So sine 90 is what now? +1 or 1. Okay, I can simply write it as what now? 1. That's for sine 90. Now how about sine 0? To find the value of sine 0 is also easy. We'll come to 0. When I trace it to the top, there is no curve. It does not touch any of this curve. When I trace it to the bottom, it still does not touch any of this curve. That means I'll trace it back to the origin. That is why sine 0 is what now? 0. Let's move over to the graph of cosine. Okay, for the graph of cosine, there is a phase, that is, it does not start from the origin, rather it starts from this maximum point. Here is how the graph of cosine function looks like. So here we have 0, here to here we have 90 degrees. Okay, over here this 90, this 90, so this is 180 degrees, and this is another 90, so we have 270 degrees, and here we have 360 degrees. Now this is how the graph of cosine function looks like. Look at the difference. This one starts from the origin, this one starts from the maximum point, of which the maximum point is +1, minimum point is what now? -1. Take note, this part is what now? -1. So I should write this one here. Okay, so that when you trace it, it touches the what now? The curve. Okay, so now to find the value of sine 0 degrees in this case, cos 0 degrees rather, cos 0. Take note, you cannot use the graph of cosine to find that of sine. You cannot use that of sine to find that of cosine. Please take note. Now, cos 0 degrees can be found when I go to cosine. When I trace it down, it doesn't touch the curve. But when I trace it upward, it touches the curve here at what point? +1. So cosine 0 is what now? +1. Okay. How about cosine 90 degrees? Now, the value of cosine 90 degrees can as well be found in this graph. When I trace it upward, it does not touch anywhere in the curve. Okay, be careful not to trace it to this end. It has to be vertical. When I trace it to the bottom, still does not touch anywhere. Okay, so since it does not show anywhere upward and downward, I'll trace it back to the origin, giving us cosine 90 to be what now? 0. That is how it is being done. Okay, that is how we find the values of these guys. Okay, so cos 90 is 0, cos 0 is 1, sin 90 is 1, sin 0 is what now? 1. Now, how about the one of tan? Ladies and gentlemen, for tangent, we cannot find, or it will prove difficult to find the values of 0 and 90 degrees. Okay, for tangent. For that case, here is what we'll do. We'll make use of the formula tan theta is sin theta over cosine of theta. This is something we're going to do right away. Okay, but first of all, I'm going to come here and draw a table for the three of them. So first things first, we're going to have sine, cosine, and then tangent. So have 0 degrees, 30, 45, 60, and then 90. Okay, I'm going to put this in a tabular form. Okay, now sine for 0, we obtain the value sine 0. We just did it. We obtain sine 0 to be 0. Okay, sine 30, we obtain it to be what? 1 over 2. Sine 45, what did we obtain as sine 45? From this first part, we got 1 over root 2. So we have 1 over root 2. And then for 60, we have root 3 over 2. And then for 90, we have 1. Now you notice that cosine is the reverse of sine when we start solving for them. Sine started from here to here, but cosine now starts from the back. In the sense that cos 0 becomes what now? 1. Cos 30 becomes what now? Root 3 over 2. Cos 45 remains what now? The same. Cos 60 becomes what now? 1 over 2. Cos 90 becomes what now? 0. And then for tangent, we found that of 45, which gave us 1 as our answer. Okay, that was what we got for tangent. And then, which other one did we do? For tan 60, we got what now? Root 3. And then for tan 30, we got this tan 30, we got root 3 over 3 or 1 over root 3. I'm going to write it as 1 over root 3. Okay, and then we're now left with 0 and 90. Since we said that tan is equal to sine over cosine, we can say that tan 0 is sine 0 over cosine of 0. Now, what is sine of 0? The sine of 0 we obtained as 0. Cosine of 0 we obtained as 1. 0 over 1 gives us what now? 0. So tan 0 is 0. Okay, how about tan 90? Now, for tan 90, it is sine 90 over cosine of 90. Now, what is the sine of 90 degrees? The sine of 90 degrees was something we obtained to be 1, and cosine 90 degrees 0. So we have 1 over 0. Now 1 over 0 is undefined, or we'll simply write it as infinity because we have infinite number of zeros inside of any number. Okay, so that is how it is being done. Ladies and gentlemen, we just did the special angles. This is video 2 of trigonometry. Okay, in the next one we're going to talk about compound angles, some more formulas that are used in trigonometry, and they can also be used to prove all these things I just did here. Okay, so here is the graph of sine, here is that of cosine, and we just treated special angles. Okay, I'm sure you guys learned 1 or 2 things from this video. Do want to leave a like, a comment, and then share to your friends. Don't learn alone. Share to your friends so that they can also, as well be helped. Okay, in our next video, like I said, we'll talk about compound angles. See you in the next video. Click on the notification bell so that when a new video is being uploaded, you get notified. Don't wait for me to come to your DMs. Okay, whether you are reaching through me on WhatsApp or any other platform. Okay, click on the notification bell so that when the video is uploaded, you'll be one of the first few persons that get notified. Okay, see you in the next video. Stay tuned.